In this example, we're going to interpret a graph of inverse proportion. So the problem here says that the time it takes to clean the windows in an office building is inversely proportional to the number of window cleaners. The graph shows the amount of time, y hours, it takes x window cleaners to clean the windows. So we know that this graph is an inverse proportion, and the main difference you see here is when we had a direct proportion, you had a straight line that was going through that origin in the graph. So that's what a direct proportion would look like. And an inverse proportion has this curve. You'll notice along the x-axis, or the y-axis, it starts up high, and then it starts to tail away, and it curves down. So what we're looking at here, we already know it's inversely proportional, but if we didn't know it was inversely proportional, we could always look at the x value when x is 1, what is y? And you see up here, y is 24. So that's where the line goes through. So that's one way we could tell what the constant is. Or we could take any point where it goes through. So any coordinate point where it goes through on the graph evenly through the y and the x. So our given point here is 212. There's another point here. This point right here is 3.8. We have another point right here that is 6.4. And it looks like we have another point here at the end that is 12.2. So to find the constant, that's what we're looking for here. To find the constant, instead of dividing y by x, because it's inverse, we're going to multiply our y and our x value. So I know right away, I already looked at this, and I know that our constant was 24. I could tell that our constant is 24 because that's when x is 1, y is 24. But if we took any of these values here that were given at any of these coordinate points, well, 2 times 12 is 24. 3 times 8 is 24. 6 times 4 is 24. 12 times 2 is 24. So we could have taken any of these coordinate points where the line goes through the x and the y axis evenly, and we could just multiply the y and the x to find our constant of proportionality. It also asks to write an inverse proportion equation. So we could use the format of y equals k over x. Y equals 24 over x would represent the inverse proportion on this graph. Part B here asks us to explain what point 212 represents. So here's what we know. 2 is the x-axis, and that's dealing with the window cleaners. And 12 is our y value, and that's dealing with the number of hours here. In the problem, it tells us that it's the time it takes to clean the windows in an office building. So what this is saying, let's take a look at 124 first, which is our first point there. What that's saying is if you have one window cleaner, it's going to take 24 hours to clean the windows. If you have two window cleaners, this is that point 212, it's going to take 12 hours to get the job done. So what this is showing is the more people that are involved, the less time it's taking to clean the windows. One of the other points that we saw was 3.8. So if we had 3 window cleaners, it would take 8 hours to clean the window, or to get the windows done. If we had 6. So if there were 6 window cleaners working on the office building, the job will get done in 4 hours. And again, another point, if you have 12 window cleaners, cleaning the windows of the office building, it would only take 2 hours to get the job done. But the point we were being asked about was 212, so we could say that if 2 window cleaners are working on the office building, it's going to take 12 hours to get the windows finished.